And action, yes. So we've been talking about sequences. Okay, today we're going to talk about a very specific type of a sequence, and that sequence is called the arithmetic sequence, and that's what we're starting off with box number 1. Okay, it is the arithmetic sequence. All right, I'm going to just do SEQ for abbreviation. So let me give you an example of an arithmetic sequence. Here it is: 3, 5, 7. Whoops, sorry, I wrote the wrong number down. 3, 5, 7. 9, 11, ... I'm telling you right now, this is an arithmetic sequence. I want you to talk to the person sitting next to you and tell them anything that you see, any recognition of any patterns or anything at all. Ready, second? Okay, I heard a lot of good things. Heard a lot of good things, but the thing that makes this arithmetic is the fact that there is a pattern that to get from 3 to 5, I would add 2. To get from 5 to 7, I would add 2. To get from 7 to 9, I would add 2. To get from 9 to 11, I would add 2. There is this constant term that we seem to keep adding to the term before it to get to the next one, right? So the definition for us that we're gonna actually choose to work with here, the definition of an arithmetic sequence is this: it's nothing more than a sequence with a common difference. And we're going to call that difference D. So what do I mean by a common difference? Here's what I mean by the common difference. If I pick any term in this sequence, say for example, if I pick 9, if I subtract the previous term, I should always get the same number. And that number happens to be 2. It needs to be constant throughout, and I get 2. If I pick 5 and I subtract 3, I get 2. If I pick 11 and subtract 9, I get 2. That's the reason why we call it the common difference. Okay? That's what makes a sequence arithmetic. It is this common difference between any two consecutive terms. Okay, let me ask you this question now. If I was going to ask you, what would be the next term in the sequence that you see here?
13.
It would be 13. Natalie, how did you do that?
I added 2 to 11.
You added 2 to 11. She added the common difference to the previous term. What's that called?
Addition.
No, starts with an R.
Recursion.
Recursion, thank you. That's a recursion. So arithmetic sequences are recursive, and we just had a little dialogue of the actual equation to do it. So I could say this: any term that I'm looking for in an arithmetic sequence is simply the term before it, a sub n minus 1, and I add on that common difference. That's exactly what Natalie just did in her head. I said, what's the next term? She's like, 13. I'm like, how'd you do it? She took the one before it, 11, and added on the common difference of 2, and she got this. So arithmetic sequences are recursive, and that's the general way that we would describe an arithmetic sequence. Take the term before it and add a common difference, and that will generate an arithmetic sequence. Okay, here is a sequence: a sub n equals 3n plus 5. In a minute, I'm going to ask you to give me the first, we'll just say 4 terms of this sequence, okay? But before I do that, before I give you a sub 1, a sub 2, a sub 3, and a sub 4, before I ask you that, does this look like anything you would potentially see in an Algebra 1 class? What does it look like to you? Thank you. You are right. You and I are on the same page. I love it. This looks to me like y equals mx plus b. Doesn't it look like that to you?
Yes.
Okay. If that does look like that to you, what would the m value be in our sequence? The slope. And what would it be in our sequence? It'd be 3. Do you guys see that? The slope would be the 3. Do you guys make that connection? Okay, so what do you think the common difference is going to be in this sequence? No. 3. It's going to be 3. I'm trying to relate to you that the slope of a line is the same thing as the common difference of an arithmetic sequence. The slope of a line is the same thing as the common difference of an arithmetic sequence. So let's go ahead. I'll prove it to you right now. If I want to generate the first term, what would it be of this sequence? It would be 8. Very good. Remember, I just plug in a 1. There you go. Plug in a 2. How would I generate the second term? What would I get?
11.
I would get 11. Plug in the third term. What would I get? 14. Plug in the next term. What would I get? Okay, so my sequence goes 8, 11, 14, 17. Is that arithmetic?
Yes.
Yes, it is. How do you know? It goes up by 3. The common difference is 3. It's nothing more than the slope, right? Remember yesterday I did tell you that sequences were functions, inputs and outputs, just like lines are functions, all right? So can a slope be negative?
No.
Yeah.
Okay.
Yeah, slope can be negative, right? So therefore, can a common difference be negative?
Yes.
Yes, it can. Very good. Okay, here's a box 3 for us. I have two sequences here for you. I have sequence A is 3, 2, 1, 0. And I have sequence B is 1, 2, 4, and 8. Okay, I want you to determine right now with a partner whether or not these sequences are arithmetic or not and justify your answer. Go ahead and talk about it with somebody else. Okay, who can I call on to explain A? Yes, Natalie, what you got?
It is arithmetic because arithmetic. I don't know how to pronounce it, but it is
Arithmetic?
Yes.
Yeah.
Because you subtract one as the common difference.
Okay, yeah, so to get from there to there, I would subtract 1. To get from there to there, I would subtract 1. To get from there to there, I would subtract 1. Right? Pick any term that you want and subtract the one before it. No matter what, you get a difference that's equal to negative 1. So yes, this is an arithmetic sequence. However, part B, what do you guys think? I'm leading you into it. What do you think? Yeah, Matt.
No, I think it is.
It is? What do you think so?
Well, you have to just times by 2. And
Ah, okay. Notice what you're doing. You're multiplying by 2 every single time. Yeah, and this is called a geometric sequence. This is what we're going to learn about on Monday. I'm glad you guys are seeing that, but does that make it arithmetic then? No, this is not arithmetic. Remember, the question was whether or not it's arithmetic. So that's just me planting the seed for you guys on Monday, okay? Okay, box 4 in this lesson is what I call the fast forward formula, all right? That's not what the book calls it. That's not what anybody else in the world calls it. It's what I call it. And you'll see why I call it that in just a moment, all right? So let's say, for example, all right, let's work with that same sequence. Let's use brown. I started with 8, then we had 11, and then I gave you 14, and then I gave you 17, right? So this was the very first term, this was the very second, this was the third, and this was the fourth. Same thing as before, okay? But let's say, you guys, let's say that I am really interested in the 23rd term, okay? Let's say I'm interested in the 23rd term. Well, we spoke about how arithmetic sequences are recursive, right? So they build off of the previous term, right? But I really just want the 23rd term. Wouldn't there be a cool way if I could just, I don't know, fast forward all the way up to the 23rd term? We would need a fast forward formula, right? If we could do that. Okay, before I tell you what it is, though, I want you guys to see if you can figure out what would the 23rd term have to be. Don't tell me, just write it down on a piece of paper. All right, I'm gonna tell you what the answer is. The answer is 74, okay? I'll tell you what the answer. You were really close, okay? All right, that's the answer. Now, hold on. Let's talk about the formula. So what I'm going to do is I'm going to give you the formula, and then we're going to take a look at the structure of the formula to see why it works. Because if you just write the formula down, and here it is, we'll do it in pretty orange for you. We'll do it's huge. A sub n is equal to the very first term, a sub 1, plus the quantity of n minus 1 times the common difference. Okay? Now that looks really, really weird, and why would that be? Okay? Many of you are on the right track, but before we get going, let's make sure we understand what each piece means. What does that piece mean right there? The a sub n. What does that mean? Yeah, exactly. That's the term that you want. Nice job. That's the term you want, right? So for example, in our example, that would be a sub what, you guys? 23. Awesome. You're on board. What do you think this one is? What's a sub 1?
The first term.
That is just the first term, right? That's the first term. Okay? What does this thing mean? The n minus 1.
That's like the 23 minus 4.
No, you're really close though. 23 minus not 4. What does it say in the formula? 1. It's just 1 less than the number of terms. 1 less than the number of terms. Okay? And what does this d mean?
The common difference.
That's your common difference, okay? Okay, so let's see here. We had this. We had 8, then we had 11, then we had 14, then we had 17, right? And this was a sub 1, this was a sub 2, this was a sub 3, this was a sub 4, and we were really interested in a sub 23, okay? So I'm going to shrink this down so we can talk about it, all right? So, oh, buzzkill, where'd it go? Where'd you go? Come back to me. So here we go. If I want a sub 23, it would be whatever the first term is plus 22 differences, and my difference happens to be a value of 3. You guys see that? So therefore, the 23rd term is going to be 8 plus 66, so the 23rd term has to be 74, and that's how we do it, and that's why that formula works. Okay, here's a sequence, 2, 6, 10. Please tell me what is the 351st term of that particular sequence. Ready, set, go. Okay, so the consensus of the class was 1,402. Is that what you guys got? Yeah. And the reason that we get that is because the 351st term has to just be whatever the first term is plus 350 differences of 4. And so I got 1,402. All right? Here we go. We're on box number 6, everybody, and this is a more challenging question. I'm going to tell you this. I'm going to tell you that this sequence is arithmetic, so you have to know that part first, okay? It's arithmetic, and I'm telling you that the 8th term is 75, and the 20th term is 39, and what I really want to know is what is the first term? See if you can figure it out with your partner. Ready, set, go. So, ladies and gentlemen, let's present this information. Let's present this information in a different way, okay? Let's say that this is a sub 1. That's what I'm looking for, right? And this is the question mark. That's the thing I'm looking for. Well, I know that somewhere down the line in the sequence, in fact, on the 8th term, that this value is worth 75. And then I also know somewhere a little bit further down the sequence that this value, a sub 20, is worth 39. So right off the bat, what does the first term have to be bigger than what number?
75.
Very good. So at least you realize it has to be bigger than 75. Okay? Now, what we need is that common difference, right? And I told you before that the difference is the exact same thing as what to a line? The slope. Okay, so does anybody recall from Algebra 1 the formula for slope, which of course is labeled as m? Yeah, Justin, what do you got? It's the change in y over change in x, which would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So check this out. If I take 39 and I subtract off 75, that's like y sub 2 minus y sub 1. So check it out. The difference, I told you that the difference was the same thing as the slope, right? So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's going to be, let me shrink this down so we can all see and put it in the same box. That's going to be 39 minus 75 over 20 minus 8. Over 20 minus 8. So that gives me 39 minus 75 is what? Negative 36 divided by 12. So my common difference is now worth negative 3. Alright? It's the slope formula. That's all it is, right? Because you know there has to be 12 slots have to be divided evenly among the difference of 39 and 75. Okay? Okay, now, have we solved the problem yet? No, we found the path, but we're still in the middle of the woods, right? We got to take the path out of the woods, all right? So, I'm interested in this. I know that a sub n is equal to a sub 1 plus n minus 1 times d. What's that formula called?
Fast forward.
It's a fast forward formula, right? Okay. Do I know any inputs and outputs?
Yeah.
I sure do. I know that the 8th term is what?
75.
And I know that the 20th term is what?
39.
Which one do you want to use? It doesn't matter.
39.
39?
Yeah.
Okay, so here's what I know. I know that this. I know that a sub 20 is going to be worth a sub 1. And don't forget that a sub 1 is the thing that we want, right? The thing that we want. Is that? Okay. I'm back to blue. Plus, let's see here. 20 minus 1 is how many? 19. And what's my difference? I found it over here. Negative 3. So therefore, how much is the 20th term worth?
30.
It's worth 39. So I know that 39 has to be the first term minus, what's 19 times 3?
Negative 57.
Negative 57. So therefore, the first term is nothing more than 39 plus 57 for a grand total of 96. And there's the first term. Okay, here we go. Box number 7 for this lesson is called the sum of a finite arithmetic sequence. So sum means what word, you guys? adding up, right? Finite means what word? Ending somewhere. Very good, ending somewhere, okay? So let me give you this sequence here. Let's say I give you this sequence, okay? And that sequence is going to be 5, 7, 9, and then 11. And okay, this is a sub 1, this is a sub 2, this is a sub 3, this is a sub 4, blah, 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 blah. And let's say I want to stop this sequence, I don't know, over at 40, okay? I want to stop at 40. I don't necessarily know what this number is yet, right? Could I get it? I could get it, right? But let's say that I'm really interested in how much all of this adds up to. That's what I mean by the sum of a finite arithmetic sequence. You guys get that part? That's what I mean by that, okay? So now I'm interested in adding up and getting an answer for the sum of a certain number of these sequences, okay? So what I'm going to do is I'm going to give you the formula, and then I'm going to tell you how the formula works. So here it is. The sum, I'm going to use S for sum. Very clever. Okay? The sum of the first n. In the case of our example, what would n be? 40. The sum of the first 40. Okay? The sum of the first 40. In our example, we're adding up 40 terms. So that's what the n means. Sum of the first 40 terms. Okay? Is going to be n divided by 2. So the number of terms you have divided by 2. Multiplied by the very first term plus the very last term. This is the formula. Alright, let's make sure that we know what all the pieces of the formula mean before we move on, and I will tell you where they come from. Okay, so let's summarize. What does S sub n stand for? I'll move up a little bit. Sum of the what? Of how many? Sum of the first n is what I was looking for, terms. I'm trying to get you guys to think in abstract, right? The sum of the first n terms. Wait, yes.
Sorry, doesn't finite mean it stops?
Yes.
It stops at 40?
Yeah.
So how would it be the first 40? Wouldn't it just be all of the terms?
No, I could start at, I want the sum of terms from 7 to 19 of that particular formula. But most of the time it's going to be...
Oh, because it goes on forever, but you want it to stop.
It's a finite amount, okay? So the first term, and then, that's all I mean. What does this part mean? N over 2, what does this part mean?
The number of terms divided.
Yep, number of total terms divided by 2. All right, good. What does a sub 1 mean? The first term. Okay, and what does a sub n mean?
The term you're trying to find.
No.
Oh, the 40 term.
The last term. There you go. The last term. The last term. Okay. So now we know what all the pieces mean. Okay. Let's go ahead and compute it. Do I have all the pieces here? I don't. No, I don't.
You don't have the last.
Okay, I want the sum of the first 40 terms is going to be 40 divided by 2, multiplied by, what's the very first term? No, the very first term is 5, okay? Plus, what is the very last term? Sugar snap. I don't know. Okay? Can I get it? Yes. How do I go from here to here? What can I do? No. Fast forward formula. Use the fast forward formula. Okay, so here we go. I'm looking for what? I'm going to move over a little bit here. Okay. What am I looking for? I'm looking for the 40th term. So a sub 40 has to be the very first term, which is what? 5 plus 39 differences. What's my difference here? 2. Very good. 39 times 2. Okay, I feel like I've lost some people, so I'm going to shrink this down and pause there for you. Okay, so what's 39 times 2?
78.
The final answer is 78?
The final answer is 83.
Okay, good. So this is 5 plus 78. So therefore, the 40th term has to be 83. Is that right?
Yep.
Okay, so I'm going to go back to my green now that I know that this is 83. Okay? So the sum of the first 40 terms is 40 over 2 multiplied by 5 plus 83. So can you guys help me out? What's the sum of the first 40 terms of this sequence? What would it be? 1,760. That's what I got. I got 1,760. Can someone verify that's what they got? Okay, I got one person that tells me that that's right. Okay.